My name is Robert Ellis Langford, and I work with mathematics every day. I can't pretend to be a budding mathematician. I can't pretend to be somebody who works with algebra so much. And though I do quite often, to be honest. It's like math is the closest thing to a cat or a dog to me. But that's not to say that I'm the best at it because I'm not. I'm really not the best at it. But I will often play around with calculations and we're mathematicians and engineers who are looking for predictive models and exacting calculations wish to have the most finite of results. I'm a miss because I will often be looking for the very opposite of that. I'll be trying to create something that is rounded, something that is truncated, something that is incredibly efficient so as to avoid there being a lot of CPU usage. So the end user has a much more efficient, much more practical product, like a product that was made in the yesteryear for a digital computer that would use less memory and less CPU overall. But I'd realized that mathematicians studying COVID right now would be hampered by the IEEE 754 floating point numbers, whether that be in single precision or double precision. And as I understand, mathematicians will often try and avoid using multiplication, but as I understand, it is used quite often. And I have a good working hack for those mathematicians who wish to use multiplication in a more efficient manner, in a manner that replaces multiplication entirely with division. How is it done? Let me show you. So let's call this n. Okay? Well, this is n and then this is m. All right? So we're using the same number for this formula. Now, as you can see, this is a variance. This is a variance, as you can see, that will depend on the numbers. But as we all know, numbers will fluctuate, numbers will change. So obviously, given the fact that division is going to be more accurate, then you'd probably be wanting to use division to create these mathematical models. And quite often, mathematical models will force you into using multiplication or will force you into using divisions. How can you get around that? You replace multiplication with division instead. Pretty simple. So let me make sure that you can see these numbers easily. Okay? Right. So let's say we have 2 times 4. That's 8. 2 times 4 is 8. 2 times 4 is 8, right? 2000.556431 times 6329.7732. Okay, right? They're the same. This is the same result. So depending on what your calculator is going to be, what your multiplier is going to be. So this could be 3, 4 dot. Yeah. So likely it's going to be the same. There are a few instances where it is not. And it's just a matter of time till you'll find such an instance like I just did now. 47 multiplied or 2000.56 times 47 with multiplication becomes 94,026.1. Yet, while I use division, it's 94,026.2. That is a serious deficit. And I want to point out that when mathematicians are making predictive models in regards to COVID, whether they're using Flowstone or whether they're using, because I'm using a mathematical product called Flowstone that allows me to make DSP, or whether you're using a product like Matlab, which is quite often employed to study mathematics, there are all the same mathematics built in. Can I use double precision math? Yes, of course I can. See, I just have to rely on another product that's built into this Flowstone product. It's called Ruby. It's just a programming language, and within Ruby, I can do mathematics. So I can output the same code, right? So I can put, okay, 2000, right, dot 56 into, so we're going to want to 0.5, put this into parenthesis, into, okay, so into 47, right? And then we're going to want to divide that also into 0.5. And as you can see, double precision would be quite a bit different. Double precision would be 94,026.32. So anybody who's relying on the IEEE 754 model is going to be extremely hampered in the way of multiplication. If you're to use multiplication for any of these models, they will be skewed. So how can you ensure that your mathematical model for your computer's predictions are accurate? It's really hard to avoid multiplication. And though there is other hacks to try and avoid the same phenomenon happening, why not just use this hack here, which allows you to multiply with division? So again, how you would do this is number, okay? Number into, okay, multiplier. There you have it. The model equals number into 0.5 into multiplier, and with that divided as a dividend into the divisor 0.5 equals the same result as multiplication, but it will be a far more accurate result. So I urge mathematicians, please, if you're going to be making predictive models with mathematics, if you wouldn't mind utilizing the hack of a DSP modeler, a DSP math hacker who's a humble audio engineer, I am sure that this mathematics will assist you in your mathematical models, and it will help to improve the validity, and finite nature of your mathematics. Thank you so much. I'm Robert from DSPplug.